All right, so just to clarify, we are on 9.4. I had, I think, 10.1 on the last video, and that was from the 13th edition. So we are in the 14th edition, so it is in chapter 9. So anyway, so now what we're going to do is we're going to step into what's called the derivative. So we're going to start with the definition of the derivative, and I'm going to give you some terminology that you're going to need to know, and then I'm going to go through several examples of how to do this. So you actually did this whole process minus one little step in 1324 when you worked with the difference quotient. So let's just go through some terminology, some background information, and then we'll jump right in. Okay, so let's say we have this function. And it could be, you know, our profit or our revenue. And let's say we want average. We want, what's the average between these 2 points? So remember, when we're talking about slope, slope is always just the basic rate of change. When we're talking about slope between 2 points, we're talking about the average rate of change. So for instance, when you take, say, 4 tests, you find the average by adding them all up. Sorry, that's my dog. Adding them all up and then dividing by the number of tests we have. Well, it's the same thing here. If this was, let's say this was month 6, and this was month 12 in our business, and we wanted to know, well, what's the average over those last 6 months? Well, we would take 2 points, and we would find, you know, we would get all the information and then divide by the number of months. Well, it's basically the same idea. We're going to get all the information and then we're going to divide it. So when you have 2 specific points, this is called a secant line. Okay, so you're finding the average. You're finding kind of overall, what's the average value, or you know, what's the average profit, what's the average revenue, what's the average cost even. So you're getting a general idea. When you bring these 2 points together, right? So we're bringing these 2 points together, and let's say I want to get how things are changing, or the slope, right here at this particular point. Okay, now we have 1 point of contact. So 1 point of contact, we end up with a tangent line. Okay, so secant line has 2 points of contact. We're looking for the average rate of change. Tangent line, we have 1 point of contact. We're looking for the rate of change, but at a very specific point, and that's called the instantaneous rate of change. So what we're doing is we are going from a secant line and we're looking at tangent line. Now we're looking at instantaneous rate of change. This is the biggest difference. This is the only difference between what you did in 1324 as far as finding the difference quotient, and then in 1325 you're finding the difference quotient, but at a very specific spot, which is called the instantaneous rate of change. Okay, so those are 2 terms that you're going to need to know. Whenever we were finding slope, so let's go back to our secant line. Okay, so we're going to go to our secant line. And we're going to call this point here X. And then this amount right here, we're going to call H. We don't know what that distance is. We're just calling it H. So that means this one, this point here, is called X plus H. It's the X value plus whatever that is. Okay? And again, at this point, we don't know what H is. All right? Well, when you find the slope, what you're doing, remember, slope is our rate of change, was y2 minus y1 over x2 minus x1, right? That was our slope formula, okay? Now, if I have my x value here, this point is called f of x. This point is called f of x plus h. Okay, so it would just be like if this was 3, this would be the y value at 3. Okay, so we're going to keep it as x and x plus h. All right, so again, we don't know what that h is. So when we're finding slope, what we're going to do is we're going to use this information. So remember, we have y2 minus y1. Here's y2, here's y1. Okay, here's x2, here is x1. So here we go. F of x plus h minus f of x. There's our y2 minus y1 all over x2 minus x1. Okay, so now watch. When I simplify this, I'm going to get f of x plus h minus f of x. X minus x cancels, so all I have left is h. This is what's called the difference quotient. Okay, this is the difference quotient. It's slope. That's all it is. It's just a way to find slope. It's the slope formula using 2 points. We don't know what h is. H is just a distance. We get the difference quotient. Okay, now how does this relate to the limits? So remember, the limit is we are taking these 2 points. We're taking these 2 points, and we want to know what's going on right here, right? So we have our tangent line. Okay, so these 2 points now come closer and closer together. Well, if this was h, as h gets closer and closer and closer together, as these 2 points get closer and closer and closer together, h gets smaller and smaller and smaller and smaller and smaller. So that distance that was wide apart is now getting closer and closer and closer together. This h value is getting closer and closer and closer together. Now what we're going to do is we're going to find out what's happening right at that point. So what is our value approaching? That's the idea of a limit. So it's approaching when h goes to 0. So what we end up with is the limit as h goes to 0 of this function. Okay, of whatever our function is. Okay, so now we have what's called the definition of the derivative. Okay, this right here, once we add in the limit, the calculus part of it, once we add in the limit as h goes to 0, now we're going to be able to find the slope, right? Because that's all this is. We're going to be able to find the slope right at that point. Instantaneous rate of change. And that's what we're looking for. In the definition of the derivative, we're looking for the instantaneous rate of change. Okay? So what this means, this is a very powerful tool. It allows us to find the slope anywhere on our graph. Okay, so the next video I'm going to show you how to do it.